Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. So what is sprinting technique for recursion? Now at a lot of times, what we are asked is, apart from just actually calculating the count of something, or actually just calculating any numeric value or a Boolean value, sometimes we are asked problems where we have to print the combinations that we have actually produced, right? In these kind of problems, this printing technique actually comes very handy, right? In this printing technique comes very handy. In this printing technique of recursion, what we actually do is, in your recursive function, whatever parameters you want to keep, you can keep it. But apart from that, you also keep a parameter named as output, which is technically a string, right? Generally, in this printing technique of recursion, what do? You keep a string parameter with yourself. And then whenever you do something with your recursion, and you have to add a combination to it, then you use this string parameter in order to create that actual printing value that you have to finally print, right? Now, this is not the best space efficient approach, because like in most of the languages, like in C++, Java both, if you have, let's say, a string str is equals to abc, and then you created a new string str2 is equals to str plus xyz, then what it will do is, it's not going to just append xyz to the end of the string. It's going to eventually create a new string, copy the first three characters abc, then copy these characters xyz. So it is going to take order of n time to actually concatenate a string. And this exists in Java also, this exists in JavaScript also, and so on. So actually, every time when you concatenate some answer to your string, it technically takes a lot of time. But in recursion based problems, where you have to use pure recursion, until or unless the constraints are very tight, we don't care a lot about complexity. because these are already unoptimized solutions. All of the recursive solutions that you are seeing mostly are unoptimized in some sense. Even if they compete with the time complexity of an iterative solution, they are not optimized in terms of space, right? And this string concatenation also wastes a bit of space because it creates a new string. These old strings remain in the memory and then it creates a new string. So although it's not the highly optimized approach in terms of printing, because you can do a bit better using arrays, right? I'll tell you about that when we'll start learning about backtracking, right? So arrays can give you a better, I would say, time and space complexity. But for the initials, for getting the understanding, keeping a string parameter output is going to really help you, in which we are going to feed our answer. And at last, when we reach the base case or somewhere, then this output actually contains one printable output, right? So we are going to solve some set of problems in which we are going to do a similar strategy where we are going to keep a string parameter and store data inside it. Although it's not going to be the best efficient approach, you can do a bit better than arrays, but in arrays you need to do a bit of extra manipulation that we will talk about. But this is the printing technique of recursion. So let's try to figure out some problems on this printing technique of recursion and try to understand how you can apply this. So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video. So in this question, what we have to do is we will be provided a number n, right? And we have to write a recursive function to print a pattern like this, right? Now pattern printing you must have already done using loops, right? And this must be a pretty simple pattern to print for you up till now, right? But the complexity comes into the picture when we have to do things recursively. That's kind of like interesting, right? So what I will do is I'll step by step break down the problem. Okay. So let's take the smaller example. Okay. Can I say that you have been given a number n, and what we have to do is we have to print n rows with each row containing n stars, right? That's the overall agenda of the problem. And to be very honest, for every row, it's kind of like identical work that you have to do. You have to kind of like do an identical work. Okay. It's nothing too much that you have to do. Okay. So what you can actually do is, let's say if I write a function f of n, and what we will expect this function to print the given pattern. Print the given pattern for n rows. Okay. So we'll write a function f of n, and we will expect that this function f is going to print the some given pattern for n rows. Okay. Now let's make things a bit interesting. If you have to print n rows, it's kind of like printing, I would say, n natural numbers, or kind of like marking attendance of n students. Again, we are coming to that example. Now, how n students mark their attendance? N students mark their attendance when the first student marks their attendance and then delegates the task of marking the attendance of the remaining student to the second person, right? Like A marks its own attendance and then give the task to B that, hey B, I have marked my own attendance. Can you now take care of the remaining attendance? Then B marks its own attendance and gives it to C, saying that, hey C, I have marked my own attendance and A has marked its own attendance. Can you now take care of this? And so on. So what I'll say is that I have to print the pattern for n rows. This is the pattern for each row. Like individual row has to print this. So how about I print the pattern for the given row, right? You print the pattern for the given row. What is the pattern for given row? You have to print n stars, right? You have to print n stars. That's the pattern for the current row. And then once you have done this, what you will say? You will say that now I have printed the initial row, right? Now the remaining n minus 1 rows, can somebody else do it for me? So what we are going to do, we are going to assume that the function f works correctly for n minus 1. And we'll be able to print n minus 1 rows. But before that, maybe we can print our own row. As simple as that. And what will be the base case? If n becomes less than or equal to 0, you don't need to do anything, right? If there is no value of n, it's less than or equal to 0, that means no rows, no columns as such, right? And this looks like pretty simple, right? Because when we have to print a pattern for a given row, we can write this as a function n of a that is dependent on n. And what this function can internally do is it can print n stars. Okay, let's see this in action. So let's see. I'll make a new file and I will say pattern1 approach1.java. Okay, pattern1 approach1.java. Okay. And then what I'm going to do, I will write public static void f, again that function f. We'll write the base case that if n is less than or equal to 0, you can just return. You don't need to do anything. And why we are doing void? Because we have to do some printing stuff. So I believe void should be good to go. And then what you can do, print pattern for given row. I will call this function print pattern for given row. Call this function to print pattern for the given row. And once you have printed the pattern for the given row, you will delegate the task that, hey, can somebody else print the pattern for the remaining n minus 1 rows? So now we have to implement this function, right? Public static void print pattern for given row, right? And it will take n. Why it will take n? Because the number of stars in a given row depends on the value of n, right? The number of stars in the given row depends on the value of n. And now if you have to print n stars in a single line, I can simply write a for loop, right? For I less than n, I plus plus, system dot out dot print star. Okay. And then I can just print a new line. Okay. So we print n stars, and then we print a new line. Okay. I believe this should be a fair approach to go, although we have to make some modifications here, but let's see what happens. If I give f of 5, if I call for f of 5 from here, and I run the code. Okay, you can see this is not what we intended. Why? Because what's happening is it's kind of like making an advanced pattern for us. If we didn't want this advanced pattern, all we wanted was one simple thing, that in every row you should have 5, 5, 5, 5, 5 stars. Now the problem is when you're calling pattern for a given row with a value of n, the value of n changes in every recursive call, right? That is something that sometimes we forget, right? And apart from that, there's a loop in this recursive approach that also we have to get rid of. But before that, if I just quickly debug it in front of you. Just a second. Okay, let's run this code once. Okay, and now let's try to debug. Okay, cool. You can see I'm calling for f of n is equals to 5, right? The moment I call for n equal to 5, you can see we have a call f with n equal to 5. This is all okay, right? Then we call for printing the pattern for n times. That means it is going to print 5 stars for us. This is also cool. You can see it printed 5 stars for us. But now the problem is you're going to call f for n minus 1. That is, now you want the remaining 4 rows to be printed. But the problem here is when you call for n minus 1, you can see another function f you called, but this time the value of n is 4. If the value of n is 4, you're going to pass 4 in the pattern for the given row, and hence it is going to print 4 stars for you. That's the problem that we are actually facing here, right? So how can we solve it? That means by just keeping the value of n, I don't think it is going to help us a lot. So let's modify our recurrence. How about if I keep the value of n and current row, kind of like n and, or let's not even keep current row, we can say total rows, right? Or we can even give it a better name, total stars. Okay, f of n comma total stars. This function is going to print the pattern for n rows with total stars in each row, right? And what we are going to do, we are going to call print pattern for given row with total stars, and then we can call for f of n minus 1. That is, for the nth row, I am going to print total number of stars, and then I'm going to delegate the task for the remaining n minus 1 rows. Maybe this can help us, right? So now let's say total stars is also equals to 5 here. Int total stars, and then instead of calling for n, we'll call for total stars, and in every recursive call total stars remain same, right? In every recursive call only the value of n will change, total stars remain same, right? Total stars remain same. And now if you run the code, you can see we have got the desired pattern, and that's what we wanted, right? So at least we are now having a correct solution, but this is still incomplete. Why? Because we are using a for loop to print the pattern in a given row, and I want kind of like a complete end-to-end recursive solution. Maybe we can get rid of this as well. Now what do we expect is that we don't want this for loop, right? I want this a end-to-end recursive solution. So one simple thing that I can do is I can have 2 recursive functions. How about we have 2 recursive functions? We have 2 recursive functions, and then one recursive function will print stars for a given row, and the second recursive function will call the first function n times to print n rows, right? As simple as that. That means currently our function f, what does it do? It just calls the function which prints a given row n times. How about we convert this function also to a recursive function? What is this function doing? It is printing given number of stars iteratively. So how about I write a function g of n which prints n stars in a line. And how do we do that? You print a star and then you assume that the remaining n minus 1 stars will be automatically printed. If n becomes less than or equal to 0, you don't need to print a star. Kind of like a similar approach, right? So let me make a new file. Pattern1 approach 2.java. I'll copy almost everything from here. But this time I'll write a function public static void g which takes a value n. It doesn't do a lot. If n is less than or equal to 0, it doesn't print anything. Otherwise, it prints a star in a single line. And then we can call for g of n minus 1. Okay? And from here, I can call for g of total stars. There is a small mistake here that we will identify. But first of all, let's run the code. If you run the code, what you will realize is everything is getting printed in a single line. Why? Because here I'm doing system.out.print. It doesn't go to a new line, right? And that's what we want. The function g has only one task. It prints n stars in a line. That means when you have called the function g and it has executed successfully, that means at this point we have n stars printed in a line. Let's go to a new line. Suppose this, you can go to a new line. How can you go to a new line? Very simply, just do a println here. And now, if you run the code, you can see the same pattern we got. So now we have two end-to-end recursive functions. There is no loop at all. And we have solved the problem. But I'm still not satisfied. We used two recursive functions. Can we enhance our knowledge and convert this to a single recursive function? Now, if you carefully see the function g and the function f, I can identify these functions in a very specific manner, right? The function g prints n stars in a row, or in simple terms you can say it works on the columns of a row, whereas the function f prints for each row. That means this function goes to each row. And if you would have implemented this solution iteratively also you would have done the similar thing. You would have kept a loop that goes to every row. Then for every row, you have to work on the column of every row. And then print a star. Right. Once you have printed a row, then you must have printed a new line. That's what you might have done in case of iteration also, right? That one loop handles you going to every row. Now in each row, you have to do the same task. So all the columns of a given row will be handled by this loop. So how about if we combine these two together and write a new function f of, now what all things we might want. Okay, we have to go to every row, right? See, we kind of like need to go to every row and we have to go to every column. So how about I keep a property row, I keep a property column, and I keep a property n. Why do you want to keep n? This will help us to identify the dimension of the square, or I would say the total number of rows that you have to do, right? So what does this function represent? The row represents the current row, column represents column in the current row. Okay, row represents the current row, maybe 0th row, first row, whatever it is, and whatever is the current row, col represents the column in that row, and n represents total expected rows. Okay, and what does this function say? It prints the pattern starting from given row and col to n minus, or you can say to nth row and nth column. That is, whatever current row is given to you, right? For example, if let's say this is the current row, this is the current column, that means we are here. So it says that starting from here, it tries to print the remaining pattern up till the nth row and nth column. Okay, and how can we do that? So just think about it. You are at a particular row, so you know which row you are at, and you know that for that row what column you are at, right? You know which row you are at, and you know for that row which column you are at. So just think about it. At a given row and a given column, what do you have to do? At this given cell, for which you know the row and know the column, what do you have to do? You just have to print a star, right? If I know that what is the current row and column, I just have to do one thing, print a star. So how about I print a star? I print a star. So you have done everything for the current row and the current column, right? So let's say if this was the pattern, let's say the value of row was equal to this, column was equal to this. Okay, that means you are here. What was your duty here? Your duty was to print a star. Now you have printed a star, very good. If you have printed a star here, what you can do is you can print the next star in the same row, right? If you have printed a star on the given column of the given row, now you should move to the next column of the given row. Can I say that? Right? For example, let's say the value of n was 4, and let's say initially row equals to 0, column equal to 0. Okay, when you are at row equals to 0, column equals to 0, what is your duty? Your duty is to print a star. Now you have printed a star for the given column of the given row. What you can do is you can move to the next column of the same row and print a star. Then you can move to the next column of the same row and print a star. Then you can move to the next column of the same row and print a star. Can I say that? It's like this, right? Let me repeat. You can even start the counting from 1, doesn't matter. Okay, for example, let's say you are on the first row, first column. So for the given row and the given column, you print a star, you move to the next column, you print a star, you move to the next column, you print a star, you move to the next column. Now if you move to the next column, can you say the value of the column is greater than n? If the value of column is greater than n, then this is an indication. This is an indication that you have printed all the columns for a given row. Indication that you have printed all columns of a given row. If you have printed all columns for a given row, move to new line, right? Or move to new row. How do you move to new row? You print new line, right? You print new line, and then you can recursively call the same function for row plus 1, column as 0, and n as it is. Why? Because you were on the first row. You have completed the first row. Now what do you want to do? You want to go to the second row and starting from the, not 0th, starting from the first column. So now you are here. So let's start again. Second row, first column, print a star. Move to the next column. Second row, second column, print a star. Move to the next column. Move to the next column. The moment you reach 5, again you can see column is greater than n. That means current row is done. You move to the new line and call for row plus 1. Row plus 1 is 3 and column as 1, right? So what you can say is that if you have to print the pattern starting from the given row and the given column to the nth row and the nth column, you can print the star for the given row and the given column, and you can move to the next column of the same row. Move to next column of same row. If at any point of time column becomes greater than n, you move to new row, first column, right? Move to new row, first column. And one more case you want to keep. If the row becomes greater than n, that means you don't need to do anything, return. All rows are printed. See, whatever we are saying, we'll just write it as it is. So we are moving row plus 1, right? At some point of time, row will exceed n. If row has exceeded n, that means you have printed all of your rows. You don't need to do anything. You just return, right? So there are two base cases here. You can see in this problem, we have two base cases. So if I create a new file, pattern2 approach 3.java, public static void main, I'll say void f. It takes a row, it takes a call, it takes a n. And what do we want? Starting from the first row, first column, I want to print, let's say, five of such rows. First thing, if the value of row is greater than n, you don't need to do anything. All rows are printed. If the value of column is greater than n, then you can go to the next row with first column n, right? All column of given row are done. Move to next row. And once you have completed the next row, you will return, right? Otherwise, just print a star. Just print a star. And in the same row, move to the next column. The only thing is, when you are going to move to the next row, before moving to the next row, print a new line. New line before going to next row. And that's it. If you run it, you have the correct answer in front of you, right? So you can see whatever I said, I wrote as it is. Whatever I said here, I wrote as it is. In recursion, always I try that the coding effort is minimal. You just have to think. In normal iterative question, a lot of time coding effort is equivalent to the amount of time you have to think. But in recursive question, you might need a bit more time to think, maybe not. But the coding implementation should be as simple as possible. If anyone reads the code, they don't have to dry run. They will say that, oh, while you were printing, if the number of rows exceeded n, that means you don't need to print anything, you return. If the number of column becomes greater than n, then you go to a new line and you call for starting the printing of the new row with the first column. That means this check is to indicate that everything is printed in the current row. Everything is printed in current row. Otherwise, you are printing the current row, you print a star and you move to the next column. As simple as that. So I hope this all three approaches, that how we improved our solution into a single recursive function, is clear to everyone. Now let's say if I have to modify my pattern. If let's say I have to modify my pattern such that if n is given as 4, I want to print something like this. How can I do that? It should be pretty simple. Why? The only difference between this pattern and the previous pattern that we solved recursively is that now in every row you don't have to print n columns. Now in every row you do not have to print n columns. Instead, you need to print column equal to given row count. That is, if this is row number 1, you have to print 1 column. If it is row number 2, you have to print 2 columns. If it is row number 3, you have to print 3 columns. If it is row number 4, you have to print 4 columns. And if you go to the code of our previous approach, this is the check which is controlling the column, right? This is the check where we are controlling when to stop printing the column, right? So let's start talking about it. Okay. So okay, my bad, just a second. Da, da, da. My Bluetooth off. Oh, my bad. Yeah. So we have the code here, right? You can see in this code, this is the part. This part controls how many or when to stop printing the current column and move to the next row, right? Because here we stop printing the current column when column is greater than n. How about here, if I say if column is greater than row, then only move to next row. Let's not wait for column to be greater than n, right? So if I copy pattern 2, right? I say that instead of waiting till n, let's wait only till row. If the column is greater than row, let's move to the next row. That's it, right? That is it. Just a second. Let's see. Oh. Did we make a mistake while creating the file? Oh, let's first of all do one thing. Let's rename this file to pattern 1 approach 3. We don't need this class file now. Okay. And then let's copy. Let's create a new file, pattern 2.java. Inside this file, let's paste our whole approach. And now you can see I'm just checking up till a row. The moment the column becomes greater than the given row, just think about it. Here the column is 1. If you do col plus 1, column is 2. You can see here the column is greater than row. Column is 1, you do col plus 1. Column is 2, you do col plus 1. Column is 3. Now column is greater than the row, right? And now if you save it and run it, you can see we got a pattern like this, right? As simple as that. So without even changing a lot of things in the code, we are able to get a new pattern altogether. And just thinking out loud, if let's say I have to print one more pattern, see, things are going to be pretty simple. Let's say we want to print one more pattern like this. What can you do? If I paste the same to same code, this time what you're doing, starting from the given row, given call, you go to n comma n, right? Now just think about it. In row number 1, how many columns do you need to print? You need to print 4 columns in row number 1. In row number 2, you have to print 3 columns. In row number 3, you have to print 2 columns. In row number 4, you have to print 1 column. So can I say on any given rth row, you have to print columns equals to n minus r plus 1. Here you can see n was equals to 4, right? So 4 minus 1 plus 1 is 4. 4 minus 2 plus 1 is 3, and so on. So I will say, instead of printing columns equal to given number of row, I will print it equal to n minus row plus 1. And if I save it, you can see we have got a reverse pattern, right? So I'm just playing with a bunch of conditions and new patterns are coming up. And you can derive this formula, right? On the first row, there are 4 rows, second row, 3 rows, third row, 2 stars, fourth row, 1 star. So you can say on any given rth row, you have n minus r plus 1 stars, right? So this condition I can change accordingly and get a new pattern. So you can see pattern printing is not very difficult if you go via recursion, and that definitely gives us a good perspective on how to actually solve questions like these.